Good afternoon, good morning, hello there. We're going to talk about machine learning, biased algorithms, and data. Oh my. So I'm sure you're exploring lots of ideas around technology and lots of ideas around bias. And what we're trying to do is throw everything together. I'm going to go through a couple of ideas. And I think the best part of what you're going to hear in the next few minutes is some of the examples I've found that are out there that nonprofits, that businesses are running into that make this really extremely real to you so that you can start thinking, how am I going to use this in my nonprofit? So I say, how does machine learning and algorithms and data help nonprofits? It's all about people are focusing on donor acquisition strategies. They're looking at how they can automate financial processes. They're looking at how they can increase their efficiencies in staff recruiting. So the question is not, will all of this do more harm than good? We're not going to go there, but how can we mitigate any harm that might come along in using some of these algorithms that we haven't thought about? So that's what we're going to dig into today, is how can an algorithm that's just plain data have bias? We can look at in terms of routine tasks. There's chatbots out there that nonprofits are using at this point already to respond to conversations via text. There are people using artificial intelligence to match their applicants with recruiters, with what they're looking for. A lot of things going on with fundraising because of all the databases. But you can have bots that scan your data, that help you identify top contributors in ways that you haven't been able to in the past. So there's a lot of good stuff going on. I'm going to go through a couple of terms that you might hear just so that we're all on the same page. You might have a little bit different view of it, but that way you kind of know what I'm talking about. This is me. I am several places in the nonprofit world. I'm Jeanne Allen. I'm a board source certified governance trainer, which means I bring in the perspective of kind of the big picture, looking at nonprofits from a governance and board perspective. I do training and teaching. I do some instructing through the Duke University Nonprofit Management Program, certificate program for professionals in the nonprofit field. One of my passions is NC Tech for Good, which is a meetup regular group we have that we bring tech and social change together, teaching nonprofits how to use technology, how to explore, how to experiment, and using tech for social change. And then I'm an occasional writer for Nonprofit Quarterly as a newswire writer. That's kind of the voice I bring to today. These are the terms I'd like you to think about. You've heard all of them. I think the more we get comfortable with some of these words, the more we start understanding where some assumptions may lay. First is we have algorithm. We hear that all the time. We know it's something to do with database manipulation so that items can be prioritized and jump up ahead. Basically, algorithms are decision-making processes embedded in code. These are opinions and values embedded in code. So when you think of it that way, you start to see how an algorithm isn't necessarily just neutral like data. And that's the challenge we get into. People think it's just data. It has to be neutral. Two things you need for an algorithm is the data and a definition of success, because you got to know what you're looking for. So the definition of success is where you can run into kind of personal interpretation. Because algorithms come out of mathematics, building models, people have this belief that an algorithm can do no wrong. And some of the exploration I've been doing and reading and ideas I'm going to bring to you just kind of explore how this could be done and thought about in a little different way. The example I heard when I was doing some exploration was great. It talked about if you were building a model for successful eating and you're the parent, one of your criteria would be you have to have vegetables. But if you had a 8-year-old kid who was building a model for what was successful eating, what was a good eating plan, they would have to have ice cream. So the idea there is everybody brings a different opinion to building a model. And that's what algorithms deal with. This comes from a book that I'm going to mention later. Kathy O'Neill wrote that, and I'm going to mention her in just another slide or two. The next term is machine learning. The most prevalent example of machine learning is what we call artificial intelligence, or AI. So basically, it's the science of automated problem solving. So this is the result where we use algorithms to come up with machine learning. It's where we give it lots of data. It can learn from that data and start predicting what's going to happen. That gets us into predictive modeling. So artificial intelligence builds pattern recognition using data sets, which I'll get to in just a second. So an example of how you might use data in the nonprofit sector, typically how we all think about it really, is that idea of moves management in the fundraising area. And the idea here is we want to deepen relationships, so we want to use our data to find the people with the most promise, either for long-term connection. People with deep connection might be willing to have more connection in terms of deeper money, moving people along. And all this is based on behind the curtain algorithms that take our data and use certain values to kick out some predictive modeling. Data sets. What are we talking about there? What the word that I've seen a lot of is called training data. So basically what they take is data that's already out there, and they use this data to get the machine to sort through and see patterns. Think of terms of applications for jobs. Somehow you gather data, which I'm going to go into in a minute, but you gather some data, and your machine eventually starts seeing the patterns, and then you're able to see future resumes and see some words or skills that might be important. I mean, it all really makes a lot of sense. What happens with the data sets is either the data you collect is unrepresentative of reality, or it can reflect existing prejudices. We're going to talk a little about facial recognition and how some of the data sets that have been teaching facial recognition were biased towards people with lighter skin, and actually people who were more male in their appearance than female. So there's a lot of error in some groups versus other groups. So that's just an example of how data sets can continue issues that you didn't think that you had. Data is just information. Technology is just a set of tools. But how we put it together in creating our data sets has a whole human element involved in it. Confirmation bias, you may have been hearing talk about this a lot lately. It's the idea that it's a tendency to search for and remember information that confirms what I already believe. And it's very hard not to fall into that when you're just doing interviews, when you're looking at information, because that's just kind of the way we're wired. So the idea behind algorithms is to understand that we've all decided that because they're mathematical, that they must be unbiased. And we tend to have blind faith in big data when we just think it's our data and we put it out there. So a takeaway I hope you're going to get from the ideas I throw out here today is how to be data and bias aware and not just have blind faith and start to ask questions. So what is the not so hidden bias of algorithms? Cathy O'Neil, who I mentioned a minute ago, and I'm going to mention her book at the end. If you're really interested, you should look into some of these books. She wrote a book called Weapons of Math Destruction. So she highlights some of the risk that happens with algorithmic, bias, and how people, because we have our discomfort with math, we tend to trust these models because we don't know how to ask questions. And we think that if we use a mathematic algorithm, that we're going to remove human bias. So that's just kind of an assumption people have made, and there are now people who are saying we can't do that, we need to pay more attention. A second resource that I'll mention, I'll show you at the end, Sophia Noble wrote a book called Algorithms of Oppression. And she had some similar views. It looks a little bit different, and she talks about the machine learning algorithms often use data that's incomplete. So it makes a flawed decision. So think to the facial recognition programs. If they rely on data sets that are predominantly white or Caucasian or light-skinned people, and they rely on data sets that are predominantly male, then they are overpopulated in some groups and underpopulated in others, and that impacts how they're going to read faces. A long time ago when they were coming up with a lot of this technology, somebody at IBM an IBM instructor and programmer came up with the word garbage in, garbage out that was used to say a computer just processes what it's given. And that's still true in many ways. And even with this artificial intelligence and predictive modeling and all that, there's still elements that we need to think about. 3 things that kind of happen in the process of moving through your organization and through the world to get to artificial intelligence. We have a people element. And the people could be our clients because they're impacted by the decisions that are made. They get rejected. They get through doors easier. They get doors shut. That could all happen based on the algorithm. The developer of the algorithms. These are people who maybe you don't even have contact with. If you're like I was in many years, I was a staff person in a nonprofit. I just worked with the material I was given. I don't feel like I have the knowledge to question developers. But I think that's what you're going to see start to happen. It's not that we question developers, but we understand there's values embedded in these algorithms, and we got to make sure we have the right values embedded. So again, when I talk about facial recognition, it's how you think about how we use data. What's the data equity element in there? Are all of our clients being seen? If we're using some form of facial recognition, are all our clients able to be seen? One of the things I read consistently and continue to hear is that machine learning and artificial intelligence does not eliminate bias, but it can amplify it because it starts at automating it and doing it behind the scenes where we're not even aware what's going on. So it's really important to realize from the people point that we have the ability to ask questions and to ask how might specific populations be impacted by the assumptions that we use to create our model. And those are the questions we can start asking. We who are not the tech developers who are using it, we can start to say, how might different specific populations be impacted? Next thing to think about is process. And across all organizations and industries, people are liking the idea of automation. We're using automation in so many ways. We're streamlining how benefits are given out. We're streamlining how people apply for jobs, identifying people who might have potential for child abuse, which gets into some of that predictive modeling. We're going to explore some real-world examples of how these processes have impacted people. Sometimes we just look at the tools or the technology piece, and what I wanted you to see here is there's a people place, there's a process place, and there's a tool place, and the tools being our technology. As Kathy O'Neill in her book said, we have to stop our fear of math and learn to question the tools. For example, search engines, we all think are quite amazing, but they do exist to drive us to commercial sites. So we need to keep that in mind. Sophia Noble's example, in her book, she proposed a really interesting thought because she goes through how, as a black woman, she was searching for black women, and the first pictures that came up were more related to pornography or sites that she didn't like, and she was very adamant about pursuing this. So her question became, what if you had to opt in to using a bias that was racist as opposed to having that be the default? So that was her question, is why do we have so many search engines that have built-in bias versus where you can opt out? But she's saying we should be able to have the default be something that's anti-racist. So it's not something maybe you and I were going to think about, but it's certainly something to think about as we move forward with developing these algorithms. What assumptions were made in creating our models? How do we use predictive tools in our nonprofit? So that's some of the ways you can start to examine these pieces. One of the examples I want to move into now is the idea of automating job applications. There's a lot everybody's kind of jumping in on this. There are a lot of programs. I see advertisements every day. It's a way that you can make sure, as we say, that it's fair because it's not a human. It saves human time, but it's also, people promote it as being very fair. So here you have an application form, and you're using machine learning algorithms that learn to make decisions around assessing employee performance and turnover, and preventing recidivism or assessing job suitability. Again, important to structure your data. So an example would be, let's create an algorithm for your workplace. Sounds simple, right? We want to create a way to create an algorithm so at our workplace we can predict who might be successful here. So we would start with data, and we might look back at, say, 20 years of who applied for jobs. We define who's been successful at our organization. And maybe we define success as somebody who has stayed here at least 4 years and had at least one raise. I mean, all that's pretty reasonable. So then we have an algorithm that's trained to look for people based on this, that over the past 20 years, who's applied for jobs, what led to success, and then it's able to find what kind of applications led to success historically. It's all being driven by artificial intelligence examining data. So then you take that and you apply it to a current pool of applicants. It might filter out women if you're in the tech world, because most of the people who applied in the past were men. And so that's some of the way it becomes biased, because it's looking for situations and occurrences that happen based on your data set, which is the past 20 years, and who applied to work for the last 20 years was a more male-dominated environment. So if the data you're working with has some inherent biases, your model will not only learn these biases, but will amplify them. So I want to give you a very specific example of this. And it's not a nonprofit by any means, but I think you'll get where we're going. So it was Amazon. Everything about Amazon is they were the key, it was key. They have been key to their e-commerce domination was automation. They had a process for everything. So they said, let's develop a process. This was like 2014. They wanted to develop a process to automate resume screening and hiring. They had a set of engineers work on setting all this up. They started using it on a trial basis. Their idea was that to use this system to go through resumes and name the top candidates, and then humans would then enter and look at the top candidates. But they had to stop the project because it became so clear that it had a heavy bias against women. However, you have to think the engineers who developed the algorithm didn't use explicit gender variables. They weren't thinking in any way along those lines. What happened is, if you look back over the 10 or 20 years of applicants prior to this date, it had been mostly men. So they trained their models to vet applicants by observing patterns to the company over a 10-year period, and that 10-year period was predominantly men. So here's a couple things that happen. One, they realized that women, certain candidates who went to certain women's colleges were disadvantaged because it wasn't the colleges that most of the applicants had been to. Number two, they even found some really interesting terms that the computer wasn't able to prioritize because it didn't belong in the data set. Example, women's chess club captain. You know, somebody who's the women's chess club captain is probably pretty good at some skills you might need at Amazon, but because it could not interpret that in a way that was positive, it just kind of skipped over it. And then the third that was interesting is there were resumes that were pushed forward or privileged because they used terms, and they discovered these terms were words men were more likely to use than women. And again, you think, how could that be? One of the words was executed, and another word was captured. So even though they learned all this, they tried to train the computer to become gender neutral, but they couldn't guarantee it would work, so they had to stop. So the lesson here is that we have job applicants using these automated systems, but the automated systems have been trained to read data based on the past. You just need to start asking questions. And because Amazon did this, they're looking forward, but this is still a pretty current story. It's pretty much a case study of what can go wrong because Amazon was so much at the front of the line in trying to develop these ideas. Next, I want to move, looking at different tools, I want to look at risk assessment tools. So this is another thing that nonprofits may use. You don't realize you're using this. Certainly if you work in the court systems or anybody who's been involved in the court systems, they've been likely involved in a risk assessment. So what this means is when you get to criminal sentencing, they take all this data that they have on the people who've shown up in front of the judge, and the judge gets a readout on who might be likely to reoffend based on this mathematical model that has been created. Here we have a story that you can go look on the website of ProPublica, and this was a story that they discovered and wrote up, where basically we have Bernard on the left, who came out with a rating of 10 out of 10. So the higher it is, the more chance of risk you are. And Dylan on the right came out with a 3 out of 10, which is low risk. So it was based on the information they used. Both of them had a drug possession charge. Dylan on the right had a prior attempted burglary. Bernard on the left had a prior resisting arrest without violence. So they were kind of equal in some ways in terms of presenting. So it goes into other pieces of this. Somebody from the law world has said we shouldn't be able to use risk assessments. They should be impermissible unless both parties get to see all the data that go into them. So again, it's that black box issue where you don't really know all the data they're collecting. One of the biases that can go into this is the idea that statistics say that white people and black people smoke marijuana at the same rates where it's illegal. But black people have been more likely to be arrested. So if you go with arrest records, you might more likely find someone who's African American who has a drug possession charge, even though there was somebody who was Caucasian who also might have had the same exposure but didn't get arrested. The key here is to have your data engineers to be translators, not the deciders. So you want to work with people who are developing the algorithms. Sometimes you say, I don't get a chance to, but you know what? Part of going and listening to a presentation like this is to start asking the questions of the other people who you work with who then are going to be in the position. So you can start from the bottom up asking questions, you can start from the top and reach outward, but I think we all can start playing a role in asking better questions. So back to this court situation. A study of the scores showed they can be amazingly unreliable in forecasting future crime. Well, it's because there's a human element in there, right? Only 20% of the people who were predicted as likely to commit crimes did so. The model embedded in the software had more false positives among African Americans than white, meaning they predicted more likely to commit crime. They were more likely to be wrong when they were predicting African Americans than white people. So there's a bias there. And that one, it wasn't correct to begin with, and two, it was more likely to have a false positive for the African Americans. Let's dig down a little bit. So dozens of risk assessments are being used across the nation. Some are created by for-profit companies, other by nonprofits. Basically, they look at a number of factors that might cause you to recommit a crime, have new criminal activity, or not appear in court. Some of these factors are related to things like your age, your current charge, and your criminal history. But then they have sometimes up to like 100 or more questions that they ask to kind of round out. And they get these questions by looking at your file or by getting you to answer some questions. But some of these questions are quite interesting because of the way they play out. So one question is, was one of your parents ever sent to jail or prison? The second question is, how many of your friends, acquaintances are taking drugs illegally? So these aren't race-based questions or gender-based or income-based, but if you look behind the numbers, what leads that? Who is more likely to have a parent that's been sent to jail or prison? Since we have had statistics that say we over-criminalize crimes that African Americans have portrayed, they're more likely to have a criminal record. So you're more likely, if you're a teenager or a young person in your 20s, to say yes if you're black than if you're white. All of that says if you start feeding that into an algorithm, it starts churning out answers that don't really work for us. I think you're probably getting what I'm saying now. And the idea is for you to start asking questions. Another question they had in here, agree or disagree, a hungry person has the right to steal. So these questions don't get directly to race or gender or economics, but the context for these questions really matters. And then they're fed into an algorithm that's that black box piece that's determined what has more value and what has less value, and it kicks out a number that says this person is more likely to not recommit crime. This one is more likely. We need to give this person a higher sentence. If you want to, so in looking around and trying to think, not everything's a bad example. What's a good example of predictive algorithmics? Baseball. I read Moneyball. Maybe you did too. We learned, if you didn't know already, how much statistics is used in baseball. So the idea of why this is a good example of predictive analytics is it shows you how we can use data in a way to make decisions, that we're not using it. The black box is not as hidden here as it is with some of these others that have to do with job applications and safety. So what we have here is data that's collected by the community. It's transparent. Everyone sees the data. People argue about it. What does this mean? This person has a hit run. I don't even know all the baseball statistics. But those of you who do know, baseball is a statistical game. So it seems kind of fair to judge a baseball player by how many hits or runs because they have some control over that. I know the pitcher has some control, but if I'm a baseball player, I have some control over my ability to read the pitch and choose a stance so I can hit the ball. So to judge a baseball player on the basis of their ability to hit or catch or run, they have some control over that. But growing up in a poor neighborhood or growing up with parents who are arrested should not be the same value as other statistics. And it's being used that way to judge people and to make decisions. So statistics that have nothing to do with your ability to control them, your zip code, could impact how you are treated by some of the different models that are out there. And the question becomes, if the algorithms don't reflect the values, who's held accountable? And I think that's where people are the people who are the major speakers in the country on these topics, that's what they're trying to throw out there, is that we should all start paying attention. Let me move now to automating processes. So this is some of the work that's already done on a regular basis. And an example would be, that was highlighted, was the Indiana Department of Child Services and their eligibility for child welfare programs and food programs. Basically what they decided, these were people, they have a legitimate legal definition of who gets the services and who doesn't. They are available to people who meet certain standards. All of that's not questionable. Certain assumptions get embedded in the system. One of the assumptions that got embedded into the minds of the people who were making the decisions, which in this case was the legislators, was they felt like the social workers who were handling the cases, there was too much of a chance they might become friends with the people they're helping and then not be able to give the right answers. They would try to help people too much. So they were concerned that it could lead to fraud because I'm the social worker and I'm helping someone who's out there and I get to know them and I know their situation, so I help them in a way that I shouldn't, or there might be fraud. Now, just to say, there were 2 caseworkers that led up to this situation and they defrauded the system for $8,000. So there was an instance of that. As we know, there's always an instance somewhere. But what they did was revamp the system. But they had some good things to say. They wanted to save money. Well, we like that. They wanted to streamline the welfare system. Well, we like that too. They wanted to replace what we call a case worker system with a task-based system, which took 1,500 or more caseworkers and moved them from being more responsive to a certain case to being more responsive to a list of tasks. So this is how it worked. Rather than a caseload of families, which I might have had in the past as a social worker, I now had a computerized queue of tasks. So everything was done through call centers and it was automated. So if I'm a client and I applied for using an application and did a form, it would then be kicked into the next part of the system, and somebody who was a caseworker A might pick it up and look at it and make sure I've answered it right, and then pass it on back into the system, and then caseworker B looks at it for some other aspect. I mean, you know what automation is. You get that. The problem is, if I did something wrong at the first level as a client, it got kicked back to me. I had to go back and do it. I have to call in. You understand this piece. I got a new caseworker who then I have to go through the whole system with, so it became quite cumbersome. And because of just simple mistakes in people filling out forms, they had a 54% decrease in denials in the first 3 years of using this in Indiana. Now, what they were trying to do, as they said, is save money, streamline the system. What they did was digitize a process. They freed up the caseworkers not to deal with paperwork, which sounds like a great thing. They said they're going to be able to increase efficiency and do their jobs, but it actually ended up being a system that was denying people rights because they missed an email because they were in the hospital with somebody who was sick, or they missed a letter, or they missed a deadline. Things that you could have called your caseworker in the past and said the deadline was yesterday and I just got home today because my mother died in another state. But, so you kind of see how this algorithm can set up a situation where it was people were being denied benefits. So again, here's a different question to ask. What if the top priority was not in finding fraud, which is the way this algorithm got developed, with the top priority, one of the top priorities be we don't want to have fraud. But what if it was developed instead to say, how do we design a system to ensure people get all the benefits they're entitled to? Not more and not less, but they get what they're entitled to. And this is one of the topics that's in one of the books I'm going to mention at the end. It's called Automating Inequality. Basically, they stopped with this program in Indiana, but at the time they were using tools and the decision-making algorithm that was embedded in the tool to outsource hard decisions to machines. And people were getting denied, as I said, at a 54% higher rate. All right, now I want to talk to you about the facial recognition. Just like I'm trying to do is run you through some examples that really hit the kind of the everyday experience you might have run into with technology. So you start to see how some of these different processes have been impacted by data sets that are biased. So the first one I want to share with you is Joy Buolamwini. I can't say her name well. She goes by Joy, a poet of code. She's a young computer scientist who has done a TED Talk, which I'll mention in the next slide. This slide is where she took from Sojourner Truth's saying, "Ain't I a woman?" And that's why I put the YouTube link there so you can go see it. It's a very interesting video where she takes pictures of people such as Oprah, Serena Williams, Michelle Obama, and other well-known women and runs their faces through a facial recognition database. And it kicked many of them back as being men. And her whole point was, AI ain't I a woman. So this is a great short video where she does a great job of just kind of getting you to realize how some of these programs work. And I think you'll enjoy looking at that. She has another video out there. These are very informative. She also did a TED Talk, which is a lower link here. The top link is the one that's picture right here. Basically, she was an undergraduate who was working with facial recognition and noticed that her face was never recognized, but some of her colleagues who were lighter skinned or Caucasian had their faces recognized. So she thought it was basically just a flaw in the data at that point. Speed forward a couple of years, she was back in grad school now, and she looks, and it's still going on, and she realizes she had to wear a white mask, which is why you see that white mask there. So this video shows how she'll be trying to get the computer to recognize her face, and it doesn't, and then she puts on the white mask, and she can be recognized, which is really kind of surprising and shocking. But you start to think how many ways we're using facial recognition. Police are using it many ways. Where's the margin for error? So it's not that I won't be recognized, but I could be recognized wrongly if it doesn't know how to read my face. Interesting enough, Facebook, who we all have heard of, has one of the largest stores of labeled faces, and they could be working they have actually a very diverse storehouse of faces. So they may be able to help. That may be one of the positive things they can do, is help change their large data set into helping facial recognition move forward. So they can be hopeful due to the amount of diversity, but the question about that is who owns the usage and the ownership, and who gets to see the data. One way they're using facial recognition data in some larger places, larger corporations, is you could go for an in-person interview and you're sitting there talking with somebody, and there is a camera in the room that's reading your face to reading your expressions. So if your face isn't even recognized, it's not going to read, or it could read the wrong piece. So the important question here would be how to ethically manage data sets with facial recognition. And then the policy implications would be, what happens when we have data sets that are being sold that are not representative, that are more representative of light-skinned or Caucasian or white people, European-based people over African or African-American or dark-skinned faces, or male faces over female faces. The first video of hers I showed you had to do with recognizing women's faces or as men. So there's kind of both ways to look at this. This was part of the study that Joy did. And basically, she took a lot of faces from a lot of different countries and set them up with male and female, dark skin, light skin. And what she found was gender was misidentified 1%. So, false positives in 1%, whereas gender in darker skinned females, the false positives could be as high as 35%. So again, think of how you're using facial recognition, how it might impact your clients. You may not be the people creating the algorithms and the data sets, but an example I wanted to bring in here is kind of like we need to be like the nutritionist taught us to read nutrition labels. Maybe you don't care about nutrition, but I bet you read a nutrition label occasionally to see how much salt or sugar or carbohydrates is in the food. And you're not a nutritionist. Well, the same way we're not data scientists, we need to start learning how to ask questions. There was a point where we didn't know how to read nutrition. Now we all know how to. So we're at a point where we don't know how to ask the right questions, perhaps, but we're going to get there. We need to start asking questions that would summarize concerns about the values. Another one I want to look at has, again, go back to some of the risk assessment. And this one's with loans and mortgages. So we have the idea of credit scoring algorithms and how they determine whether you can get a cell phone, a mortgage, a credit card. So what's important to think about here is these algorithms are based in the question, what is credit worthiness? And they start to define the whole algorithm based on credit worthiness. So here's a catch to that. If you go in to buy a car and the salesperson is working with you and you have to borrow money to pay for the car, riskier customers, so high-risk customers, tend to prefer longer loans, 5 years, 6 years, because it's a lower payment. Low-risk customers, meaning people who are more likely to have regular jobs or ability to pay back, they favor shorter term because they like the idea of paying less interest. So what happens is the salesperson begins to nudge those high-risk applicants to take the shorter, a little bit shorter than they might be comfortable, which means it's a larger payment because they say it'll help your credit readiness, it'll help your credit score. So then somebody who knows they can't quite afford that big payment jumps into a bigger payback schedule, faster, larger monthly payments, and they end up not being as able to make the payments. So it's because the algorithms are based on people who takes shorter loans, have a better risk factor. So people know what the risk factors are, and they try to convince people to move into that. Salespeople are nudging people into bad decisions. People are burdened by higher monthly payments. They're less likely to pay. So you kind of see how these algorithms get set up. So I'll talk about a couple of examples here. People get denied because they didn't pay their loan last time on the car, and this time they now have a bad credit rating when they go in to get their cell phone. So what does all this mean? I gave you a couple of examples here, the idea of job applications, the idea of facial recognition, of welfare automating processes. I've tried to embed it in a lot of areas where you could see how data and algorithms aren't as neutral as we think. So 4 ideas for you to think about when it comes to actions. What you need to consider, this is always kind of fun to say, we need to consider the unknown unknowns. So the idea that when Amazon was the engineers were creating their algorithms to look at job applicants, they weren't thinking about bias in gender. They just didn't operate, so they didn't know what their unknown unknowns were, and they had to stop the system. They tried to revamp it. So that's something to think about. Just it's out there. The second one is we have imperfect processes. So a lot of the data used for building and testing come from the same places. One of the things that our friend Joy that I mentioned has said is the same data sets are used for many different artificial intelligent algorithms. So if it's wrong at one point, it's wrong in several places. Number 3, the lack of social context. The idea that computer scientists frame problems differently than social scientists and than nonprofit people do. And the last one, which I'm sure everybody in the nonprofit world gets this one, is the idea of what's the definition of fairness? What's the definition of success? So that's what we need to be clear, because that's one of the key parts you need in algorithm. What does success look like? For example, does fairness mean the same number of each race in a pool, the same number of men and women, or does it mean proportion? We need the same proportion based on statistics for your area. So what is fairness? Some actions you could take would be to think about, I liked reading this. This is an example I read where it talked about loan approval calculations. You get back that you're rejected. So instead of just telling people they're rejected, what if instead there was a piece added into that said, here's what you could do to reverse this decision. You need to save up this much money, you need to save at this rate, and that would make you be a better candidate. So we give people information. So what we don't get right now is just kind of a kickback that says you're not accepted. But what if we started changing the system to say, here's some information, and you can now change the outcome. So we move more towards that transparency we see with baseball. People have data, and they know what to do with it. I already mentioned the idea of trying to learn to ask questions the same way we learn to read labels for food. And another idea would be make some of these conversations routine. Get your board of directors to talk about tech and how it impacts your organization. Talk to your friends, talk to staff, go to conferences and ask the experts to start talking about these topics. Send in requests for webinars. Ask for more ideas around how do we learn to ask the questions? How do we learn to pay attention to the algorithms? How can we facilitate ongoing communication and learning about this? And I want to share with you one example. It's an organization called M Relief. They are a nonprofit startup. But what they did to make, as an example of making data transparent, is you can go to their website and you can put in all the information depending on what state you're in, and they will ping, as they say, ping your state organization with the data to see if you would be eligible or not. So you don't have to put it all in and then get a reject letter. So you're putting in the data they think that you need to put in. And what they do is they ask you, if you're doing food stamps in some states, it's 20 pages, it's a 90-minute phone call, it's 3 or 4 appointments. So what they're saying is you can use our website to find out if you may in fact qualify. So if you definitely don't, you don't have to spend all the time or the humiliation or embarrassment of applying for something you're not going to get. What they do is they take your data, they make it anonymous, they ping the state system where you live, and they come back to tell you, yeah, it looks like you might be qualified, or no, it looks like you're not eligible for this. So then you, as the client, can make a decision as to whether you want to release all that data by going to the state agency or not. Because you say, well, gee, if I'm not likely, maybe I'll try anyway, but at least you go in knowing you might not likely to be eligible. So these are some ideas of how we need to learn how to use machine learning algorithms in ways where we can give information back to people. A couple of resources I want to share with you. 3 books that I think are, if you're at all interested, I say you should look through some of these. The one on the left, Virginia Eubanks, talks about welfare rights organizing. One of the examples she talks about is, while we all think the cards they get with the welfare benefits loaded up on a card, they can go to the grocery store and use that like a debit card, nobody knows, and everybody thinks that's great. One of the examples she talked about in her book, is somebody who uses that said, yes, but now social services can track everywhere I spend my money. So things, the back end you don't think about when you're coming up with these systems. Kathy O'Neill in the middle, Weapons of Mass Destruction, she talks about inequality and algorithms. And on the right, we have Sophia Noble, who talks about the idea of the search engines being racist in some of the assumptions, and how if you put in certain words, what comes up, and how hard it's been to change some of that. Excellent resources, some articles. You'll have access to this website, so you'll be able to see these articles. They're just some. Number 3 was the one that had to do with the 2 men who were getting a sentencing. The other articles are just ones that I've found pulling together. Just if you're interested, they're just great articles to read to realize what's going on. I said, go out and ask questions. So learn more. And then I just want to close up by saying, look at the people, the process, and tools of your organization. Break it down. Look at the clients you're serving. Look at the situations they may come in. There may be needs that you need to fulfill you never thought about. You may be promoting systems you didn't realize, looking at some of your processes, what has been automated that you haven't thought about that might be closing doors to people. Don't just look at the tools. My call to action to you is to become more aware. Read these articles. Look at those books. Ask questions. Ensure that your nonprofit's processes and the people you serve, that you're serving the people right, you're asking good questions, and help your clients be able to, that you work with, to better access some of these algorithms. So the key to take away from me is for you to think about how you can best educate yourself so that you can ask better questions. Thank you very much. I hope that I have kind of shaken up some of your thinking so that you go out there and you start exploring new ideas. Thank you for the time. Bye.